Hello everyone, welcome to today's class. This is Teacher Simon taking you through Core Mathematics paper 0580 stroke 11 for May June 2025, and this is part 2 for questions 18 to 26. Okay, now question 18 is coming from properties of angles. The diagram shows two straight lines intersecting two parallel lines. This is the one here. Not to scale means that when you put your protractor here, this angle is not going to be 110, okay? They have just drawn the diagram and then represented those angles there. Then part A, find the value of x and give a geometrical reason for your answer. When you look at parallel lines, always, these are the properties that should come into your head, that you have a z here, so this angle here is equal to that angle here, or something like that. This one here is equal to that. These ones are called alternate angles. Are we there? Those are the properties. They ask the geometrical reason. Then you also have, if these are the lines, then you have this angle here, okay, then corresponds to this one here. These ones are corresponding angles. You see that? Just like you can have this one here, if it is B, even this one will be B. Now, this one actually introduces us to another property. If I have B here, and then I have A here, then A plus B will be equal to 100. I mean, yes, 180 degrees. Why? Now, this is what we call interior angles on parallel lines. They add up to 180 degrees. Why? Because this angle here, this one here, is B because it is corresponding to this one. Are we there? And then this angle here is going to be A because it corresponds to this one here. Now, you can see that by taking this point here, these angles are on a straight line. So A plus B is equal to 180. The same thing here is equal to 180 when you add them. So, and also maybe another thing is this angle here will also be equal to A, this one here. These are opposite angles. So this one will be equal to B. When you cross your hands, okay, the angle up and the angle down are equal. So those are what we call opposite angles. So we should be thinking in that line. Now let's come to this question, part A. X is equal to what? Now I want you to look at this one here. Look at this line, then come here, and then come here. Look at X here. Do you see the 50? Alternate angles, right? So I'll just say that X is equal to 50 degrees because these are alternate angles. Alternate angles. You can add on alternate angles are equal. Or you just say alternate angles, full stop. Then part B, find the value of y. We are also supposed to give the reason. Where is y? Y is here. So if y is here, is there an angle? Look at this line here. Look at this one here. There is a transversal line here. Then look at this angle here. You see that? These ones are corresponding angles. So y is therefore going to be equal to 110 because these are corresponding what? Angles. You just write the statement corresponding angles. If you want, you can say are equal, no problem. Okay. Then next, we are supposed to find the value of z. The value of z. Z plus 50 will always give us 110. So we say sum of two interior opposite angles give the exterior angle. We actually call it the exterior angle property. Okay, exterior angle property of a triangle. Okay, why? Let me show you something. If I have, let's say, this is A. Let me just prove it down here so that you get it clearly. So I'm going to put my angles here. Let's say this is A, this is B, this is C, and then this is C, and then this one here is D. Now, first of all, A plus B plus C, A plus B plus C is equal to 180 degrees, okay? These are angles in a triangle. Angles in a triangle. Add up to 180 degrees. Then C and D, they are angles on a straight line. So C plus D will give us 180 degrees, okay? Angles on a straight line, add up to 180 degrees. You see that? Now these two equations, I can equate them. So I can say this is my equation 1 because they are all equal to 180. This one here is my equation 2. Okay, equation 2. So this means that equation 1 is equal to equation 1, 2. Now, they are all equal to 180. So one side of 180 is A plus B plus C. Then in the other equation, it is C plus 1 plus D. Now, what is common in both? It is the C. So when I cross the C's out, I'll get A plus B is equal to D. So you see that the interior angles here, interior opposite angles, when you add them, they give you the exterior angle. So that is what is here. Therefore, Z here shall be equal to 110 minus 50. And this one will give us 60 degrees. You see that? Or if you want, you can actually say that this one here will be what? These are angles on a straight line. This will be 70, not so. Then 180 minus 70 minus also the 50. You see that when you add these two, you get 120. So then 180 minus 120, you get your answer as that 60. So I can say alternatively, you can say 180 minus 110, because these are angles on a straight line, we get 70. Then Z, therefore, is equivalent to 180 minus, get that 70, you add it to the 50. Okay, that is 120, and then 180 minus 120, then you get the 61 degrees. So use the one that is easier for you. Question 19 is coming from probability. A box contains 10 counters. The counters are either red or green. The ratio red counters to green counters is 1 to 4. Shireen picks a counter at random, notes its color, and puts it back in the box. She then picks a second counter at random. This is what we call picking with replacement. You pick, you read the color, then you replace. Okay? Now, we need to know how many are the red counters. So, number of red counters is going to be red corresponds to the 1, right? So we shall have 1 out of the total, which is 5 when you add total ratio. Then times what? The 10. So that means here we shall have 2. And then the number of green counters will be 10 minus 2, which is 8. Or I can say 4 out of 5, then times 10. Then this one will give us what? 8. So this tree diagram here means that every time you are picking, you are either picking red or green. Okay? If we were having maybe another color, then we would be having a third one here. Something like that. Okay? Or maybe put it here. Now, before you pick any red, what is the probability of picking red from there? First of all, there are 2. So we shall put 2, then out of the total, which is 10. You can simplify this one and we say 1 over 5. Okay? Now, for green, it will be 8 out of what? 10. Or you could say 4 over 5. The 4 here, then divide by the 10. 4, then divide by the total, which is what? 5. The total ratio. Okay. Then you have replaced, that means the reds are still 2 over 10. Okay. Green, they are still 8 over 10. 2 over 10. And then 8 over 10. Okay. I said this one can be simplified to 4 over 5. This one can be simplified to 1 out of what? 5. Okay, so that is that. You can write this one here and also here. Then this one you can also put it there or there, whatever you want. So that is that. Let me actually shift this and put it down here. Then next, find the probability that both counters are green. Probability of both green. So that means the first one you picked was green, then followed by another green one. So we just multiply through the what? The branches here. So we shall have that 8 out of 10, then times 8 out of 10. You see? And this one will give us 64 out of 100, which you can write as 0.64. You can simplify it, you can leave it like that, no problem, because they didn't tell you to write it in the simplified form. But I can say divide by 4. If I divide this one by 4, right from here, I can say by 2. Then we have the what? Just like I said before, we can have 4 over 5, then times 4 over 5. Not so? So 4 over 5 times 4 over 5. What do you have? So this one is going to be 16 over 25. So I can write 16 out of 25. Or from here, I can divide through by 4. 64 divided by 4, that is how it comes to be a 16. And then 100 divided by 4, that is how it comes to be a 25. You see that? Okay. Question 20. This one is coming from statistics. The scatter diagram shows the price of petrol per liter and the number of liters sold at a petrol station on each of the 10 days. This is the one we are given, and based on the way these ones go, so if let's say we try to draw a line of best fit, it is decreasing going to the right. So as the price per liter increases, then the number of liters sold has to decrease. So that is a negative correlation. Okay, so if the prices are always high, what are you going to do? You are going to reduce the consumption. So you will buy liter by liter. Okay, so the liters you will be buying now will do what? Will reduce. Or you will reduce going everywhere because the fuel has become what? Very expensive. And the more you move, the more the number of liters to be consumed. Part A, they're saying these are the results for 2 more days. And we are supposed to plot this information on the scatter diagram. So we have price per liter is 1.68. We need to know the equivalence of a small box here. One small box is equivalent to These are 5. Every time we are adding, they are adding a 0.05, because if you add a 0.05 here, you get 1.45. This is the one here. Then again, a 45 plus 5, that is a 50, 55, 60, something like that. So that means one small box is equivalent to 0.05. That is what they're adding on. But then we are dividing by what? By 5, because these are 5 small boxes in here. And this one will give us 0.01. Okay. Now 1.68. This is 65, 6, 7, 8 will be there. 3 small boxes beyond the 1.65, and then 90. How about here? One small box will be equivalent to, they are adding 100. So we shall have 100 divided by, how many small boxes are there? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those are 10. Then we divide by 10. This one will then give you 10 units. That means 90 will be here. So 90, and then 1.65, you take 3 more units, so it has to be here. Okay. So our point will be here. Now to make it, you can put the cross, okay, or just to make it distinct from the rest, to show that I've plotted, I can use that circle. Okay, no one is going to penalize you which kind of plotting you're using, so it's just to make them distinct, such that when the examiner is marking, can easily see what you're plotting. Okay. Then next, we are going to have 1.47 and then 380. 1.47 and 380. 1.47, we shall go 2 more here, and then 380. So we move 8 there. So it will be here. That is the point there. Then what else? What type of correlation? This one is negative. Okay, you either say negative or positive. You see points are going like that, that's negative. If they go like that, that is positive. Okay. Then see Roman 1. On the scatter diagram, draw the line of best fit. So here you are supposed to balance, okay, balance the points below and above the line. Balance them. So when we draw, you make sure that the points that are above and below are balancing relatively the same. You see that? And so let's now try to balance. So when I draw mine here, I can see this is 1, 2, 3, 4, 5, and down here I'm having 1, 2, 3, 4. So, and I've gotten 3 points that are on this line here. 1, 2. Like, how many most points are fitting on that line of best fit? The points which are fitting there, are they many? But when you draw, you try to balance. So approximately that is what we are having. Then we can use the line of best fit in order to find the missing value. So they are saying, see Roman 2, one day the price of petrol was $1.55 per liter. Use your line of best fit to estimate the number of liters sold. So I'll come to this one here, and I look for 1.55, which is here. Then I draw, and then I make it meet the what? This line here. Then read off this way. What you get is what you write, okay? we are not going to get the same answer, maybe as that in a marking scheme or what, because you are not drawing the same line of best fit. So they are going to give you a mark based on what you have drawn, okay? Based on what you have drawn. So if you draw a line with the negative gradient here, it is going to be considered, and then the answer which you get from there, okay? So from mine here, I can see that this is 1, 2, 3, 4, 5, 6. That is 260. So my answer is going to be 260. But you might find when another person has 270, 275, okay, 200 what. So based on my line of best fit, you write the one which you get in the marking scheme. You find when it is 271, 5, okay? Okay, so this is the one in the marking scheme. But based on what I've drawn, that is what I have. So don't write an answer like, let's say in the marking scheme, it is 275. You write 275, yet here, when you draw yours, it doesn't give you the 275. So they will mark you based on what you have gotten from your graph. If you write an answer that is different from what they can get using your graph, then you get it wrong. Is that clear? All right. Question 21 is coming from circle theorems, okay, and trigonometry. Points A, B, and C lie on a circle center O. Then they say work out the angle BCA. BCA. So this is the angle here. But you can see that if this one is a diameter, then the angle in the semicircle is always 90 degrees. So angle ABC is equal to 90 degrees. We say angle in semicircle is always 90 degrees. Even when you look at circle theorems, we have that theorem that says that first of all, you have this point and this one here. Then you have a chord that moves from this point, then it goes to this one here, and then comes back to this point here. So this angle which is formed here is actually a half of the one that is at the center. So this one will be 2x, okay? This point here, then it makes an angle at the center. Again, this point here, you look at the chord that goes to the circumference of a circle and then comes again up to this point. So angle at the center is twice angle at the circumference. Now I have this point here and this one here. The angle they make at the center is what? 180 degrees. And then look at this chord here going to B, then going down here to again C. So this angle here, okay, is a half of the angle that is here. So what is a half of 180? Isn't it 90? So that's why I was saying angle in the semicircle is always equal to 90 degrees. Okay, now angles in a triangle always add up to 180 degrees. So angle BCA is equal to 180 degrees, then minus the 90, then minus the 39. Already this one here gives us a 90. So if this one is already 90, that means these two angles must also give us what? 90, okay? So we shall add, I think, a 51 there. So this one has to be 51. As simple as that. Then question 22. We are saying A is equal to 2 cubed times 3. 2 cubed is 8 times 3, 24. Then B is equal to 3 squared, which is 9 times 5, that is 45. Find the highest common factor. So the highest common factor, we keep what is common, okay? So you have 2 times 2 times 2 times 5, times 3. Then we have 2, this is 3 times 3 times 5, okay? So what is common? We are seeing a 3 and a 3, nothing else. So highest common factor is what? Is 3. You see? Then, when we go to the LCM, let me show you something small here. I'm going to have two numbers, okay? So I'll put them in these two circles here. Something like that. One number, we have seen 3 is common, so I'll leave 3 here. So I'll have, this one is 2 times 2 times 2. So 2 times 2 times 2, then times the 3 will give us one number. You see that? Then this other number has 3 here. Then we shall have times, there is a 3 and then times 5. Not so? Yeah, this one that is left here. So this one is giving us B. This one is giving us B. This one is giving us A. Okay. Now the LCM is when you get all of these. Okay. They'll give you the LCM. Then the one that is in the middle here is always the highest common factor. So LCM here is going to be 2 times 2 times 2 times 3, because when we draw a table, we are dividing all those numbers until they become 1. So you divide until when this one is gone, and also for B. So using the Venn diagram, that is what we can get. Then this side we have a 3, then times what? A 5. So already this one here is the A, which is 24, right? 24 then times 15. So what do we get here? Or I can begin by saying 9 times 5. 9 times 5, that is 45. So 45 times 8, what do we get? This is 40. And then 8 times 4 is 32 plus 4, 36. So that means our answer is going to be 360. So the LCM of 24 and 45 would be 360. Question 23 is coming from transformations of objects. And here in O level, we look at translation by a given vector. Then we have reflection in a certain mirror line. We have enlargement by a given scale factor at a certain center, and also rotation through a given angle and the direction. Is it clockwise or anti-clockwise? And then the center of rotation. And here they are saying on the grid, draw the image of T after rotation, 90 degrees clockwise, center, 0, 0. Now here you can use a tracing paper. Use a tracing paper. Or a protractor. Now since I don't have a tracing paper here, I'm going to use a protractor. So the center is 0, 0. Okay, so mark that point. Then I'll bring my protractor here. When I bring the protractor, I'll put it, we are supposed to move clockwise. So clockwise has to be this way, not so, like that. Now I'm going to put this one here. I connect it to each of the object points. Okay, now we move like this, connect this one there. That is a diagonal through a box. 90 degrees is along here. Okay, 90 degrees, something wrong here. You see this line here, that is the one. So we are supposed to go also, since this one was one diagonal through the one box, even this one has to be one diagonal through one box. So that means the image has to be here, one diagonal here through one box. Okay, then I will note this one here like that. Then after that, I can continue, put onto this other point here. You can see that this is a diagonal through 3 boxes. Already our 90 is here. So when we draw through that 90, we are supposed to move. You see this diagonal is through 3 boxes. So I also follow 3 boxes, 1, 2, and 3. So the image has to be there. You see that? So we shall have our point where? Here. Then lastly, of course, this one here, let me put this one back. Okay, I need to first put off this, and then put a point here. Then next, put this one back here, and then we connect to this other point here. It's a diagonal in how many boxes? 1, 2, 3, 4, right? Then when we go to 90 here, we draw through, 90 is passing there, but we must move. We should follow that diagonal through 4 small boxes, 1, 2, 3, and then 4. So that is the one there. That means I will have my point there. Then you can remove your protractor, and then you join. So this one here, this one here, and also that one there. You can even see that this part here, which was standing vertically, now is lying down like this. You see? So if I get this one here and I join it to this one, they will form an angle of 90 degrees. You see that? Then this one, which was horizontal, is now vertical. As simple as that. So this one I can shade it if I want, or if not, then you can leave it, no problem. And then they didn't tell us to label it, but I can just put this is part A, just to be so smart and very organized. Okay, you can just put it there. The examiner sees it very fast and then gives you your marks. Then part B, describe fully the single transformation that maps T onto A. T is the object, then A becomes the what? The image. Now, when you're describing, I have already said, look at the number of marks which are given. If the number of marks are 2, if the number is 2 here, then you are going to either have reflection. So you tell us it is reflection. Then in the middle line, you give us the equation of the middle line. Or you can say translation. You tell us that it is translation by vector what. So those are the 2 marks. But if there are 3, then it is either rotation or enlargement. Because if it is enlargement, you will say enlargement, that is 1 mark. By scale factor, which one? That's another mark. And then center of enlargement, that's also another mark. And then for rotation, you will tell us that it's rotation, that is 1 mark. Then through, let's say, 90 degrees clockwise. So you have to tell us the angle and the direction, that is 1 mark. And then the center. You see that? That is for description. Now let's go to this one here, B. We are seeing that these are 2 marks, so we should think about reflection and or translation. But when you look at T and A, the way they are looking like, that is automatically what? A translation. So they moved to the left. How many units there? Then they also moved down. You see? So I'm just going to look at that part there and maybe make this line here a little bit dotted so that it doesn't interfere with whatever was drawn there. So here we are moving how many units? 1, 2, 3, 4, 5, 6. Okay, 6 units to the left. So that's minus. And then this is 1, 2, 3. Then 4. Then those are 4 units. downwards, so that is also negative. You know y is positive up here, way above x-axis, and negative below x-axis. So when we move down, it's a negative. When we move up, it's a positive. So here I would say this is a translation. So that is the first mark, translation by vector. The vector is going to be -6, -4, like that. So you will have one mark here and then another mark there. See that? Then part C, describe fully the single transformation that maps T onto B. You look at the marks, so it is either enlargement or rotation. But since we did rotation in part A, they can't be mad to again give you rotation in what? In C. So this has to be enlargement. Actually, for enlargement, you have to look at the object and the image. One of them has to be bigger than the other, or one of them has to be smaller than the other. So you can see that this one is bigger than this. That means this is enlargement. So how are we supposed to find the scale factor? We are going to draw lines through object points and their corresponding what? Image points, and the corresponding image points. Where these lines meet, where the lines meet is the center of enlargement. Now we need the other factor. The other task we have is to find a scale factor of enlargement. So the scale factor, how do you get it, of enlargement? There are two formulae you can use. The first one is you get the image side length, okay, then you divide by the object side length, okay, or you get image distance from center of enlargement, then divide by object distance from center of enlargement. Okay, so we shall write that this is enlargement, then by scale factor. Let's find the scale factor. It is image side length over object side length. So this is the image side length I can take. So this is 1, 2, 3, 4, 5, 6. I write 6. Then the corresponding side length is 1, 2, 3. So we are dividing by 3. That means the scale factor here is going to be what? 2. Or you can look at this one. 1, 2, 3, 4. Then divide by 1, 2. The corresponding is this one, okay? So that one is also giving us what? 2. So scale factor 2. Then center. We need to find the center of enlargement. What are those two coordinates there? Now, I said you get the what? The ruler. You join. You get this point, join it to this one. Just draw lines all through. Draw lines through object and image points. Okay. So I'll get this point here, connect it to that one there. Like that. I'll get this point here, connect it to that point there. Then I draw through. You see? Now, you can see that these lines have already met here. Even if you just use 2, they have already met here. So that is the center of rotation. But to prove it, I will get this one here, connect it to that one, but then just continue. So do you see that they all meet at the same point? But not to interfere with whatever is drawn, so you make these lines dotted like that. When you make them dotted, it just shows that you did the work on the what? So that you produce neat work. That is what we are having there. So the center, it's on y-axis. So on y-axis, x is 0 and y is a -2 there. So that is what we are having. So those are the 3 marks. 1 mark is here to say that this is enlargement. Scale factor is here. And then the center is this one here. And then you get your 3 marks. Okay? So that is that. By the way, the other way I said you can find the scale factor of enlargement is by using the image distance from the center of enlargement out of the object distance from the center of enlargement. Now, let us look at let's say this one here. Image is here. Let me use red. The image is here. Then from the center here. Now you can see that this is a diagonal in 3, then a diagonal in 3. So I will take this one as 1, then also this one is 1. So those are 2. So I will say that is 2. The distance is 2, okay? Or if you can use your ruler and you measure, but better to be looking at the corner points where these lines are passing, okay? Corner points, corner points, corner points, like that. Then for the image distance, object distance is of course 1 here. So you get 1. And also, and of course this one is going to give you 2, right? And also another thing is if the object and the image are on the same side, okay, on the same side of the center of enlargement, then the scale factor is what? Positive. So the scale factor is here, the object is here, the image is also here. They are all on the same side of enlargement. On the center of enlargement. But if, let's say, the object was here and this image is instead this other side, then the center of enlargement would be negative. Okay? Question 24 is coming from fractions workout. These ones here. Now you can see that these fractions are what we call mixed numbers. Okay? So they are saying give your answer as a mixed number in its simplest form. So we have to first convert the mixed numbers into improper fractions. So 3 times 1, that is a 3, then plus 1, that will be a 4. So we shall have 4 over 3, then plus 4 times 1, that will be a 4, then plus 3, that will be a 7, then over 4. Using the butterfly method to get the common LCM, the common denominator, you multiply these two, then 4 times this, and then this times that. So you will have 3 times 4, and then 4 times 4, then plus 7 times 3. So 4 times 4, that is 16, plus 21, then out of 12. 16 and 21, that is 37, not so. So that is 37 out of 12. But 12 has multiples, 12, then 24, then 36, then 48. So 37 is here. It is bigger than 31 by 1. So we shall have, those are 3 multiples, right? So 3 multiples have gone. So I'll write 3 whole number. And then 37 minus 36, you will get a 1. So 1 out of 12. Then next, 25, part A, write this one in standard form. So in standard form, we must have A, then times 10 to the power of n, where n can be positive or negative integer. And then a has to be ranging from 1 then to less than 10. Why do we say less than 10? Because we can have 9 point something, then times 10 to power, whatever. But you can have 10, then times maybe 10 to the power of. These won't be two figures. I mean, it won't be one figure. So we are supposed to have one significant figure on the left of the decimal point. So if this is the decimal point here, you must have exactly one significant figure. Okay. Now let's come to this one here. 32500. The decimal point is here. So you have 1, 2, 3, 4. Remember, we must have one significant what? Figure. So this will be 3. Then 0.25. If you want, you can add on those 2 zeros, but that is wastage of time. Then we say times 10. How many places have we moved? 1, 2, 3, 4. So power 4. As simple as that. Okay. Then write this one as an ordinary number. So we shall have 5.6. Then we move 3 places onto the left. 1, 2, 3, like that. So we put zeros here. That means we shall have 0.005 and 6. By the way, if it is times 10 to the power of negative 3, you should have 3 zeros on the left. As simple as that. Then this one is a 4 here. That means after this decimal point, you must have 4 digits. And these are the 4 digits. You see that? 2, 5, then the zeros which were eaten up. And the last question is coming from solving these simultaneous what? Equations. I'm going to use elimination. Okay, elimination method. I have to eliminate one of them, either x or y. Since they don't have the same coefficients, so I can switch them. Let's say if I'm eliminating x, I will multiply. Let me say here I'm eliminating x. You can use substitution, and you make one the subject of the formula, one letter the subject of the formula, then you substitute in the other equation. You can use matrix method. Okay, many methods. So eliminating x, we shall have 2, then x plus 5y, which is equal to 5, then 3x plus 4y, which is equal to 11. The LCM of 2 and 3 is a 6. That means I'll get this 3, put it here, and then the 2 here, put it down here. So 3 and then 2. The reason as to why we are doing so, such that when we multiply all through, I'll have the coefficients of x being the same. So this is 6x. This will be 10. Is it 10? 15. Because 5 times 3 is 15, right? 15y. And then this will also be 15. Then multiply here everything by 2. You get 6x. And then plus 8y, which is equal to 22. Now you can see that the coefficients of x are the same. Is all 6. Then, since the signs are the same, positive, then we can subtract. If the signs are the same, you subtract. If the signs are different, you add. Because if this one was a negative, then to eliminate this one here, I can't say that now subtract. This one will become 12. Not so. So you have to instead add if the signs are different. But now, since the signs are the same, they are all positives. Even if they are all negatives, you will subtract. Still they will go. Okay. All right, now let's subtract. So of course this one disappears. Now 15 minus 8, you get 7. So this one will give us 7y. And then here 15 minus 22, that's a negative 7. So meaning y will be equal to negative 7 out of 7. And this one gives us a negative what? 1. Then I can substitute in any of them to find the value of x. So using the first one, 2x plus 5, our y is a negative 1, is equal to 5. Then 2x here will be equal to 5. This is a negative 5. When it crosses, it becomes a plus, right? That means x is going to be equal to, this is 10, then we shall divide by 2, and x becomes a what? A 5. So that means our solution here, x is equal to 5, and y is equal to negative 1. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.